In 1928, at a military testing ground in Czechoslovakia, trials of new armored vehicles were underway. A group of high-ranking officers watched an experimental machine moving along a dirt road on caterpillar tracks. After coming to a halt, the crew exited the vehicle and performed technical adjustments on the running gear, which took about 15 minutes. Afterward, the same machine continued its movement on the highway, now on automobile wheels, reaching a speed of 22 miles per hour. This model, weighing over 7.7 tons, was designated the Kolohousenka 7K. It was a project of the interwar period aimed at solving a key problem of tracked vehicles of that time: slow travel speeds on public roads and the rapid wear of tracks on hard surfaces. The history of its development began in 1923, when the Czechoslovak Republic, formed after the collapse of Austria-Hungary, was working to form its national armed forces. The experience of the First World War had shown the significance of tanks in combat, and the country's military leadership realized the need to create their own armored units. Due to a lack of experience constructing such machines and the high cost of purchasing foreign models, which created a dependence on external supplies, the command turned to local industry. Soon, German engineer Josef Vollmer, known for his participation in creating the A7F tank, offered his services. Due to the terms of the Treaty of Versailles, which banned Germany from producing and developing tanks, German specialists looked for opportunities to realize projects abroad. Vollmer presented the Czechoslovak military department with a project for a light tank with a combined wheel and track drive system. The concept involved using wheeled mode for fast movement on roads, while preserving the life of the tracks, and track mode for overcoming rough terrain. The blueprints were handed over to three major industrial enterprises: Skoda, CKD, and Tatra. The companies combined resources to work on the order. Skoda was responsible for the armament and hull, CKD for the chassis and transmission, and Tatra developed the engine and control systems. Joint activity between competing manufacturers was an atypical practice, but the scale of the task required a consolidation of efforts. The project received the designation KH, an abbreviation of the Czech Kolohousenka, or wheel caterpillar, where the number indicated the engine output. The first prototype with a 50 horsepower engine was assigned the index KH50. The engineering basis for the machine was the chassis of the German Hanomag artillery tractor, which had proven itself in service. Designers substantially reworked the original base, introducing a mechanism that allowed for changing the type of drive. The chassis design combined standard automobile wheels and tracks, with the wheels placed inside the track assembly. When moving on tracks, the wheels spun freely. To switch to wheeled mode, the crew used jacks to lift the hull, dismantle the tracks, and stored them inside compartments. After that, the machine was lowered onto the wheels to drive on roads like a car. The process of changing the drive mode took about 15 minutes, which met the technical requirements of that period. The welded hull, made of 0.55-inch steel sheets, provided protection against bullets and shrapnel. The crew consisted of 2 people, a commander gunner and a driver mechanic, seated in the front section. Armament on the first prototypes was limited to a single 0.55-inch machine gun in a rotating turret. A 50 horsepower engine mounted in the rear allowed for speeds of up to 22 miles per hour on wheels and 10 miles per hour on tracks. The operational range reached 186 miles. By 1928, two experimental KH-50 models had been built and sent to the proving grounds. The vehicles demonstrated an ability to switch travel modes, hit high speeds on the highway, and run quieter than their tracked counterparts. The concept envisioned rapidly deploying these machines over public roads, then switching to tracks for combat operations. However, during operation, numerous technical glitches began to appear. The mode switching system proved unreliable. There were reports of mechanisms jamming, lifting devices failing in the field, and rapid wear on the track mountings. On one unit, the transmission gave out while moving cross-country. On the second, the hull lifting system failed right there on the testing ground. Troubleshooting required significant time and effort from the crew. The Acceptance Commission recorded these defects in their final report. They concluded that the KH-50 was unfit for mass production in its current form. The military department refused to adopt the model, and the prototypes were returned to the manufacturers. The data gathered during testing was used by engineers at the design bureaus to upgrade the project. One prototype was dismantled to analyze component wear, while the second, having suffered critical damage, was scrapped. The developers decided to create a new machine, taking the identified mistakes into account. The factories began designing a reinforced turret capable of mounting a cannon, completely overhauling the chassis and introducing a more powerful power plant. The modernized version received the designation KH-60, reflecting the machine's equipment with a 60-horsepower engine. This modification represented a technical evolution of the previous version. The 10-horsepower increase in output was intended to compensate for increased weight and improved dynamic performance. The engine was positioned in the rear of the hull, with access provided for maintenance. The cooling system was refined to ensure stable engine operation without overheating in high ambient temperatures. The transmission received reinforced components and bearings designed to handle the loads of driving on both wheels and tracks. The key change in the KH-60 design was the installation of proper artillery armament. Specialists at the Skoda plant designed a cylindrical turret housing a 1.45-inch Model 1927 gun, also known as the Skoda A3, developed for light armor and possessing corresponding armor penetration capabilities. The ammunition loadout included armor-piercing and high-explosive shells, allowing the vehicle to be used for infantry fire support. The rounds were stored in internal racks within the hull. The turret was equipped with a manual traversing mechanism, allowing the commander to fire in a full circle. Turret armor thickness was 0.55 inches, matching the protection level of the hull. The KH-60's running gear underwent significant modernization. Engineers at CKD reworked the wheel-to-track transition mechanism to improve reliability and simplify operation. The design of the jacks was reinforced and equipped with a hydraulic drive to make lifting the hull easier. The track chains were made of high-quality steel, ensuring the links would resist deformation during repeated assembly and disassembly. The wheels were reinforced and fitted with wider tires to optimize weight distribution on the road. Extra shock absorbers were added to the suspension, smoothing out the ride and reducing vibration when moving over rough terrain. Field trials began in 1930 at the same site where the KH-50 prototypes had been tested. Military officials evaluated the new model, specifically looking at how it addressed the flaws found in its predecessor. The KH-60 demonstrated improved handling. On tracks, it could negotiate soggy ground, trenches and inclines. On the highway, moving on wheels, it clocked speeds of up to 19 miles per hour, an acceptable figure for an armored vehicle weighing over 8 tons. The gun showed satisfactory accuracy against targets several hundred yards away. However, the design flaws in the system for switching between wheels and tracks hadn't been fixed. The process of switching modes required a significant amount of time and physical effort from the crew. The 15-minute standard might have been acceptable in theory, but in a combat situation it created tactical risks. The crew was forced to leave the safety of the hull, operate jacks, and move heavy track belts to stow them in boxes or put them back on. During this time, the vehicle remained stationary and vulnerable. Observers noted that while the wheel and track concept had theoretical advantages, in practice it came with serious operational difficulties. Nevertheless, work on the project continued. 2 prototypes of the KH-60 model were built and underwent an extensive testing program on various types of terrain. The vehicles were tested on country roads, swamps, sandy areas, and rocky slopes. The machines showed satisfactory results, especially when driving on wheels over hard surfaces, where their speed was comparable to cargo trucks. However, the procedure for switching to the track drive still demanded considerable time and effort from the crew. Developers concluded that a third modification was needed to fix the shortcomings of the wheel and track design. In the early 1930s, engineers from Skoda, CKD, and Tatra held a meeting regarding the future of the Kolohousenka project. Despite the improvements, the military departments expressed doubts about whether the tank was worth adopting. However, the project wasn't closed, given the worsening international situation and the arms build-up in European countries. In the end, permission was received to develop a final version of the machine. When designing the new model, priority was given to installing a more powerful engine and boosting firepower. The tank received the designation KH-70, which corresponded to its power output of 70 horsepower. An inline 6-cylinder water-cooled gasoline engine made by Tatra gave the machine the necessary dynamic performance. On wheels, the 8.8-ton armored vehicle reached speeds of up to 22 miles per hour. When using tracks, speed dropped to 10 miles per hour, but cross-country capability increased substantially. The range remained at 186 miles, allowing for long marches without refueling. The fuel tanks were placed in protected compartments on the sides of the hull to minimize the risk of damage if the vehicle came under fire. The armament on the new modification underwent significant changes. Instead of an artillery gun, the turret was fitted with 2 0.31-inch Schwarzlose Model 712 machine guns. This technical decision was driven by the need for a high volume of fire to support infantry and neutralize enemy personnel. The ammunition load consisted of several thousand rounds stored inside the hull and turret. The design allowed for single or paired firing, while the standard cooling system permitted sustained fire without the weapons overheating. A distinctive feature of the KH-70's appearance was the special structure at the rear of the hull. A metal frame, extending beyond the vehicle's dimensions, was designed to help cross wide trenches and ditches. When navigating obstacles, this tail section served as an extra pivot point, preventing the vehicle from getting stuck or tipping over. As the tracks cleared an obstacle, the tail section was the last part to leave the trench, making it easier for the tank to climb out onto level ground. This design feature significantly improved the KH-70's cross-country performance when traversing fortified positions full of ditches and trenches. The armor specifications remained unchanged. The 0.55-inch steel plates on the front offered protection against small arms fire and shrapnel from light artillery. Engineers considered increasing the armor protection, but that would have led to a critical increase in weight, reduced mobility, and excessive strain on the suspension. So, the decision was made to leave the armor as is and focus on other technical aspects. The crew complement remained the same: 2 men, a driver positioned in the front of the hull, and a commander gunner in the turret operating the machine guns. The KH-70 underwent testing in the mid-1930s against a backdrop of deteriorating international relations. With tensions rising across Europe, nations were closely analyzing their neighbors' military developments. This Czechoslovak wheel and track tank caught the eye of foreign military experts, who saw it as a potential solution for the rapid deployment of armor. Italy showed particular interest, as their military leadership was looking for ways to improve unit mobility in mountainous terrain. An Italian delegation arrived in Czechoslovakia to examine the prototype. During the demonstration, the vehicle's capabilities were put on display, switching between wheel and track modes, crossing trenches using the tail skid, and firing the twin machine guns at targets. Following the inspection, the Italian representatives arranged the purchase of a single unit for detailed trials. The Czechoslovak side approved the export deal, seeing it as a chance to earn foreign currency and showcase their national industrial achievements. The KH-70 was delivered to Italy, where it underwent a rigorous series of tests. Italian engineers analyzed the vehicle's components and pushed it to the limit in various conditions, including mountain roads, swamps, and rocky terrain. The machine demonstrated satisfactory performance, particularly its high speed on wheels, which helped save wear and tear on the tracks. However, the Italian specialists reached the same conclusion as their Czechoslovak colleagues. The process of switching between wheels and tracks took too long and required the crew to get out of the vehicle, which reduced its combat effectiveness. Ultimately, Italy declined to mass-produce the vehicle, and the test model was put into storage and later scrapped. The remaining machines continued to serve in Czechoslovakia, but there weren't enough of them to form full combat units, so they were used primarily for crew training and demonstration purposes. By the mid-1930s, the Czechoslovak army found itself in a difficult strategic position. Geographically, the country was wedged between potentially hostile powers and had a critical need for modern armor. Yet the Kolohousenka project failed to live up to expectations. Military leadership decided to focus their resources on traditional tank designs, and as a result, orders for the wheel and track vehicles were halted. Only 4 units or various modifications were ever produced: 2 KH-50s, which were soon written off due to technical issues, 1 KH-60, and 1 KH-70. The remaining machines, representing an attempt to build a universal tank, were handed over to training units. Crew training was unique, as cadets had to master operating the vehicle on both wheels and tracks. During training, instructors required the drivers to drill the procedure of switching between travel modes over and over again. It was a labor-intensive process. They had to precisely position the jacks, remove the heavy tracks, stow them in special side bins, and then do it all in reverse. Despite the complexity of these operations, this kind of training gave them solid experience in maintaining the running gear. Commanders practiced firing the Schwarzlose machine guns and studied tactics for light armored vehicles. Beyond training purposes, these machines were occasionally used to patrol border territories, where tensions were constantly rising by the late 30s. Neighboring states were showing increasingly aggressive intentions, which demanded a military presence in strategically important areas. The Kh-60 and Kh-70 were sent to potential conflict zones to demonstrate defensive capabilities, even though it was obvious these models were obsolete before they even saw service. The tanks moved along the roads of the border regions, with crews monitoring the situation, ready to engage their weapons. The design of these dual-drive machines caught the attention of the local population. In 1938, the international situation escalated sharply. Under pressure from foreign political factors, Czechoslovakia was forced to cede part of its territory. The Czechoslovak army, which stood ready to repel aggression, never received the order to commence active combat operations. The Kolohousenka series vehicles remained in their garrisons while the political regime shifted. The troops watched their nation's sovereignty vanish, yet this equipment, designed for defense, never saw combat and played no part in how events unfolded. Command issued orders to preserve the hardware, even as the army's combat readiness declined. By March 1939, after Czechoslovakia completely lost its independence, the national armed forces were disbanded. The entire fleet, including the experimental wheel and track vehicles, passed under the control of the new administration. Foreign military engineers analyzed the captured models to see if they could still be used. The design caught the specialists' eye, but testing proved these machines held no significant combat value. They noted insufficient armor, weaponry that didn't meet modern standards, and an overly complex mechanism for switching between wheels and tracks. Because of this, mass adoption was deemed pointless. Still, they weren't scrapped immediately. The machines were handed over to occupation units for auxiliary duties. The Kh-60 model was sent to guard a warehouse on the outskirts of Prague, where it was used as a stationary post. The crew consisted of local personnel given brief training for guard duty. The Kh-70 model was used for patrolling the countryside, where the specific dual-drive system might have been useful. Moving the vehicles between towns served to demonstrate a military presence. During operation, the technical condition of the units systematically deteriorated. With no production of original spare parts, repairs were a major challenge. Mechanics had to improvise parts or adapt components from other types of vehicles. There was progressive wear on the tracks, a drop in engine power, and failures in the drive switching system. By the early 1940s, both vehicles had fallen into disrepair, struggling to move even short distances. The leadership made the decision to cease operations and send the equipment to be melted down. These tanks, representing an attempt to realize a non-standard engineering concept, were scrapped. The experimental Kh-50 and Kh-60 models, which had been used for training purposes prior to the occupation, were also written off during this period. They were stripped for parts to repair other units, while the remains of the hulls were sent for scrap. Not a single example of this series has survived to the present day. Information about them is available only thanks to archival photographs, technical documentation, and the testimony of the personnel who operated these machines. The final stage of the vehicle's service was marked by the complete exhaustion of their service life. Machines that were once viewed as a promising development sat idle without proper maintenance. The KH-60 finally failed in the spring of 1940 due to a seized engine during a patrol. No restoration work was performed. Left on the roadside, the hull was partially stripped by the local population. The KH-70 remained in service longer, but by the autumn of that same year, critical track wear and a failure of the wheel-switching mechanism made further movement impossible. The machine was towed to a military depot, where it sat out in the open until it was finally written off. By the beginning of 1941, all units of the Kolohousenka type were officially removed from the registry and sent for metal recycling. The wheel and track combat vehicles of this series have completely fallen out of use, and today the only proof of their existence lies in archived blueprints and a few grainy photographs. Initiated by Czechoslovak engineers, the project never met its performance targets, proving that even theoretically sound ideas can fail when tested in the field. The Kolohousenka tank has gone down in history as an experimental machine that combined disparate technical solutions. The attempt to merge the advantages of wheels and tracks in a single design was unsuccessful. As a result, the vehicle was never adopted for service, nor did it find any use in the civilian sector. Researchers view this episode as a closed chapter in the search for engineering compromises, one that, despite the lack of practical results, is still worth studying to understand the evolution of weaponry during that era.